You gave me life, soft like the moonlight. You take my wrongs, helping me feel alright. Your art of listening, lifted by angel wings.
This all started when we would see CTs and MRIs of babies who had bad brain injuries, and nobody understood exactly why the injuries happened the way they did. So one of the reasons we actually started doing the MRI was to figure out how they happen and why sometimes we saw some patterns and other times we saw other patterns. And if you could understand the patterns, then maybe you could figure out a way to prevent the injury. And I think it's going to be possible to monitor therapy by looking at specific injured pathways and focus on those specific pathways to find methods that work better than others.
Dreams, your love wrapped around my soul. Where I'd be without you, only God knows. Your heart is the truest part of me. Yeah, you're the heartstring leading me home.
All of our achievements in the last 20 years are a result of a lot of different radiologists, a lot of different scientists. We've had wonderful project managers, and they're the ones that keep our cohort together so that we can keep all of our patients. We have wonderful basic neuroscience, and we've had great child neurology and great neonatology, and just wonderful nurses, the neonatal research nurses, and every one of those people is an integral part of the research team.
Here at UCSF, we do a lot of hardware and software development to improve the image acquisition for imaging newborns. In terms of hardware, we build MRI coils, which are signal receivers to get the actual data from the brains. Then also, in order for us to take these patients down to the MRI suites, we also build MRI compatible incubators. We're not only interested in anatomic imaging, but also functional imaging, which include water diffusion, perfusion, resting state fMRI, and obviously UCSF strong suit metabolic imaging.
Among other innovative research approaches, we analyze how different parts of the brain are interconnected. Knowing how these brain networks are affected, for example, by premature birth, can help us improve therapy.
We've used advanced magnetic resonance imaging techniques to learn about brain development, and we've done so even before birth. Many women with babies who have congenital heart disease are diagnosed before birth, and so we've been able to enroll babies before they're born, study their mothers, and then we study them before and after surgery.
Through the information that we've gained from the research studies, we're now able to counsel the parents about what to expect for their child's future development. And one of the greatest things about doing brain imaging is that very often we have good news to tell the parent.
In order to obtain good outcome data, we work very closely with the clinical follow-up team, and we mirror the time points for our study outcomes with the time points that they would be coming in for clinical follow-up.
Keeping in touch with families and getting to know them and the children and seeing them grow up. That's the best part.
With memories we're saving.